Today I am going to present a webinar on the topic Fundamental and Concept of Earthquake Engineering. I thank to Mr. Rohit Jain sir and Mr. Adam that they offer me this opportunity to present this webinar. And without wasting time, I will start this webinar. Now, just may I start?
Yes, sir.
Okay. Okay. So first, the main topic is that what causes earthquake. As we can know that Earth is made up of these three layers: crust, mantle, and the inner core is there. And where hello,
Yes, sir. Yes, sir. You're audible.
hello. Okay, okay. Sorry. So I was telling that it is made up of three layers: crust, mantle, and core. The outer core is liquid in form, and the mantle has the ability to flow. So what happens means what causes earthquake is that the convective flow of material which cause the earth and some of the portion of the mantle they slide on this outer portion of this core which is very hot, and due to this sliding the earth mass it take place into pieces, and due to that the tectonic plates form. And as we can see that there are seven major tectonic plates: Indo-Australian plate, Eurasian plate, Pacific plate, North American plate, South American plate, African plates. So what happens? The interface between plates where the movement has taken place, it is known as the fault. And when this fault suddenly slips, then the earthquake happens. Now, when earthquake happens, how the ground shakes, how we are going to see that whether the structure will behave after the shaking of ground. So, first of all, that the instrument which is used to measure this earthquake is the seismograph. There are two major types of seismic waves, which are love waves and P waves. Some waves are surface waves and some waves are body waves. As we can see in the diagram, those are body waves which moves inside the soil, which means underground, and those are surface waves. They pass on this surface. So what happened? Suppose where the earthquake happens inside the ground, that is the fault rupture point, and from here the waves will pass through on the top, and the waves will move. Some waves are horizontal waves, some are vertical waves, and these waves will move and it will reach to the structure and they will shake the structure. And next is that when the waves will come, when the ground will shake, what is the intensity and what is the magnitude of this earthquake shaking? So the major point is that whenever earthquake happens, we see in news that news is showing that the earthquake happens with this magnitude and with this intensity. So what happens that first of all, what is magnitude? It is a quantitative measure of actual size of the earthquake. Uh, if we want to understand by the example, somewhere we have seen that magnitude is of 4.5 magnitude earthquake, 7 magnitude earthquake. So what does this mean? What is the meaning of this earthquake? So what happens when the earthquake comes? This magnitude actually it was invented by the Professor Charles Richter, and it is measured on the scale which is known as local magnitude scale. And suppose if, at a place a magnitude of earthquake, suppose 7.7 comes, and at different place magnitude of 6.7 comes. So if we see the difference of number between 6.7 magnitude earthquake and 7.7 magnitude earthquake, The difference is of only 1. But when we see on actual energy level, the 31 times more energy is released. The difference of single means numerical earthquake will affect in the terms of energy 31 times more severe earthquake will be there. Now, what is intensity? It is a qualitative measure, and generally we see intensity in Roman numerals. So basic difference, if we can see in example, suppose a 100 volt bulb is there, and another bulb is of 200 watt. So the power of 200 watt is more than the 100 watt bulb. So the watt bulb, we can say that it is a magnitude example, and at near place to bulb and at far place to bulb, intensity will decrease. So as we move further from the bulb, the intensity will decrease. Same happens in earthquake. As we move from center of earthquake to some distance, the intensity goes on decreasing. So these are the basic difference of magnitude and intensity. Next, what are the importance of seismic design codes? In India, the Bureau of Indian Standards has given certain codes. So what is the main purpose of giving this seismic design code? It has 4 virtues. First is good structural configuration, second is lateral strength, third is adequate stiffness, and fourth one is good ductility. So the first one, which is of good structural configuration, it basically deal with the size, shape, and structural system which carry the load. And the main concept is that to flow inertia forces from ground, means a direct and smooth flow of inertia forces to the ground, means whenever the earthquake comes, direct it should pass through the ground, otherwise there will be damage in the building. Second one is the lateral strength. The maximum lateral force that can resist is such that the damage induced in it does not result in collapse. So whenever earthquake comes, we should see that the building is of such type that it should give certain warning before collapse. It should not direct collapse, otherwise there will be loss of property and human life. Third one is adequate stiffness. Inadequate stiffness, the lateral load resisting system, means the horizontal, we can say that load, such that the earthquake induced deformation do not damage its content under low to moderate shaking. Further, I will show that what is low to moderate shaking. So whenever earthquake comes, it should resist a certain horizontal load, or we can say that lateral load. Fourth one important point is ductility. The concept of ductility is that it should undergo large deformation under severe earthquake shaking, even after yielding. Means there should be certain deformation, otherwise if earthquake comes and building collapse, there will be certain loss. So this is improved by the favorable design and detailing strategies. Whenever we are designing a building, we should check and give proper design and certain strategies to follow when we are designing the earthquake resistant building. Next, in India, what are the different seismic zones? Earlier, Indian Bureau of Indian Standard has given code of 1893 Part 1. It was in 2002, means generally many books and many places, this code is followed, 1893 2002, that was 5th revision. But in 2016, the code was revised, and the new code was given in 2016. A slight difference is there, where in previous codes zone was divided into 5 categories, 1, 2, 3, 4, 5. But in the new code, the zone is only 2, 3, 4, 5. Now, the zone 5 is the most seismically active zone, and zone 2 is the least active zone. What is means by most active and least active? As we can see in the diagram, the Gujarat region is divided into different force, means patterns. Somewhere it is showing 2, 3, 4, 5. So these are the seismic zones where zone 5 is there, the we can say that the severity of earthquake will be very more. It will cause more damage to the building and structure. And where the zone 2 is there, where minimum fatality will be there. So as most of the people are in Vadodara, we can say that it is in the zone 3. So these are the division of zones. Likewise, the whole India is divided into certain these divisions 2, 3, 4, 5. Next, how it affects on structure. These are the different examples or diagrams. We can see that when Bhuj earthquake was there in 2001, so we see that the first one building, it was of stone masonry walls. So whenever we see the stone masonry walls, uh, when earthquake comes, it will damage the top portion, mainly top portion, because there is not direct flow of waves, means from top to bottom. At certain point, whenever the path flow breaks, so it will damage the building. So whenever, so first example was this, that at certain places stone masonry walls was there. It is in Uttarkasi earthquake, and second one damage we can see is the Bhuj one, where column got damaged, and it is the base column. Whenever foundation of base column damages, whole building will collapse, and we can say that building breaks into two parts, and at one side it got tilted, and the bottom columns damage was main. So this shows that what is the importance of designing walls and columns for horizontal earthquake forces. As previously we see that the lateral strength and adequate stiffness is important in designing seismic codes. So whenever we are designing building, we have to see that whenever the horizontal forces or whenever earthquake comes, the column should be designed in such a way that it should not start to collapse immediately. Next one is earthquake design philosophy. What are the design philosophy which are given by the Indian standards? First one is under minor but frequent shaking. As previously I told you that low to moderate shaking. So these are divided into three categories. First category is under minor but frequent shaking. The main member of the building that carry vertical and horizontal force. Main members are like beam, column. These are the main members which carry vertical and horizontal force should not be damaged. Otherwise, what will happen? Whenever earthquake comes, if beam and column got damaged, so directly the building will collapse. So the main member should not be damaged in minor shaking whenever minor earthquake comes. However, building parts that do not carry load may sustain repairable damage, like almirah, window. These are the members which do not carry the load system. They can means small damage are allowed and which are repairable, but main members should not be damaged. And second one is under moderate but occasional shaking. The main members may get repairable damage, while other part of the building may be damaged such that they have to replace after the earthquake. If certain part of the building get damaged, like suppose a small portion of wall get damaged or window or certain portion get damaged, they can be get repaired by the after earthquake. But the main members should be under repairable damage. They should not damage fully. Means after earthquake they can be repaired. And last one is under strong but rare shaking. Uh, Strong means generally it is of magnitude more than 7. Very rare earthquake comes when means like Bhuj earthquake was there, and it was more than 6.5 or around that, or 7. So these type of earthquake comes very few. Means in 50 years, one or two type this earthquake comes. So these are very rare, and under this strong and rare shaking, the main member may sustain severe damage, which are not repairable even after building. But main point we have to know that building should not get collapsed. Otherwise, there will be loss of human and property. So these are the three basic earthquake design philosophy. As we can see that this diagram, under minor shaking, a small portion of the building which are not carrying load, they get damaged and they can be repaired after the earthquake. And in moderate shaking, the portions like beam column, they get a small damage and they are repaired after the earthquake. But in the last one, whenever the strong earthquake comes, we are seeing that whole building get collapsed. But means whole building is not going to collapse, but the main load members like beam, column, slab, they get failed and they are not they cannot be repaired after the earthquake. As this is the live example where diagonal crack happens in column, and these are unacceptable. Means whenever earthquake comes and whenever these types of damage are there, so it is not repairable. So we have to means there will be certain times that we can escape from the building, but the building will be of no use after the earthquake. Now, whatever the acceptable damage, brittle failure is not allowed. Whenever any building, the acceptable criteria of this is ductility. The main is that the beam and column or whatever it is, it should be ductile. So in first example, it is showing that behavior building performance during earthquake. The first one is this ductile, showing that brittle performance. Brittle means the building will get collapsed. If the brittle nature is there, whenever the shaking will be there, whole building will get collapsed. But whenever the ductile performance will be there, we can say that from graph also, if ductile performance will be there, it will give time to escape from the building. The second, this example is of brittle failure. Whole building get collapsed, means beam or column is totally damaged, which are not repairable even after earthquake. So whenever ductility comes, how to make building ductile for good seismic design? So the first criteria which is followed for this is ductile chain design. What do you mean by ductile chain design? We can see from the diagram that there is a two chains showing. First one is original chain and second one is loaded chain. In original chain, it is showing two links. One is ductile link, and at the in center it is showing ductile link, and the corners and intermediate it is showing brittle link. So what happens when we give load to this? The ductile link will get extend. There will be certain deformation in ductile link. Same thing happens in building. Means it, the brittle link, it will not get deformed. Whenever load is applied, the ductile link will get deformed and it will yield before breaking. So it will give certain warning before breaking. So if ductile link is the weak one, if we are providing the ductile link as a weak one, the chain will show large final elongation. If brittle link is the weak one, then the chain will suddenly fail and it will show small elongation. So for this purpose, we are providing ductile link to be means in the center one. So if we have to provide such a ductile chain, we have to make the ductile link to be the weakest link. Now in the second diagram, we can say that it is for the reinforced concrete building design. Whenever we are designing the building, the main concept we have to apply is that strong column, weak beam design, and which are unacceptable is weak column, strong beam design. So in reinforced column building design, we have to follow this one. So it is better to make beams to be ductile, weak link than column. So if beam are ductile, so it is no problem. This means that designing RCC building is called strong column, weak beam design. So whenever we see any place, it is showing that a strong column, weak beam design. So it means that building should be designed in the chain form, and where the failure of column can affect stability of the whole building, but the failure of beam can cause localized effect. So we have to follow this strong column and weak beam design. Now, how do earthquakes affect reinforced concrete building? How these earthquakes are going to affect reinforced concrete building? In image, I have shown that masonry building. Now, these are the example of reinforced concrete building, and we can see that a graph is showing where at base, where the ground is there, the force is very high, and from bottom to top the severity of force decreases. So the ground floor is going to damage very much. So what we have to adopt is that whenever we are designing the building, we have to provide the ground floor, or means foundation level should be very means uh, we have to give a strong reinforcement in the foundation, so that whenever earthquake comes, it will resist the means shaking. So what we have to follow, that the flow of inertia forces to foundation should be direct. There should be not a break of forces. Walls or columns, we know that are most critical element in transferring the inertia forces. But in traditional construction, most of we can see that floor, slab, and beam receive more care. Whenever we see a building construction is there, floor, slab, and beams receive more care attention during design and construction than walls and columns. And walls are thin, and most of the time they are made of brittle material like masonry. They are poor in carrying horizontal inertia forces along the direction of their thickness. So failure of masonry walls have been observed in many earthquakes. In the past, poorly designed, constructed, reinforced columns can be disastrous. Means if the columns are designed very poorly, so there will be much damage to that building. So the failure of ground story column resulted in numerous building collapses during the earthquake, and the we can see that example of 2001 Bhuj earthquake. This happens that most of the reinforced concrete building get damaged because of this weak column. So whenever we are designing, we have to follow the strong column, weak beam theory. Now, how beam behave in RC building, how they resist the earthquake. These are the two diagrams. First diagram is showing two types of failure. First one is flexure failure, second one is shear failure. So whenever this beam design is should be there, we have to take care of these two type of failure: flexure failure and shear failure. What happens in flexure failure? As we can see from the diagram, that beam gets sagged, means sagging is there under beam, and due to that sagging, what happens? There will, if suppose more steel is present on the tension phase, if more steel is present on the tension phase of the building, so it crushes in compression. So this is the brittle failure and is therefore undesirable. Means this is undesirable. This is type of means brittle failure. So what we have to do? We have to provide more steel on means we can say that more steel on tension phase is not desirable. On tension phase, more steel is not desirable. The ductile failure, we can see that it results in various vertical cracks, and starting from face, and it is going to it can go towards the mid depth also, from face to mid depth also. So these cracks are visible. That is, it starts from face and it passes, means it goes slowly to the mid depth of the beam. Second one is the shear failure. These are the two portions of this buildings where we are showing the beam, in beam, flexure failure and shear failure. So, what is shear failure? In shear failure, is shear crack is inclined at 45 degree. Here we can see from the diagram that crack is at 45 degree to the horizontal, and it develops at mid depth near the support, where support are provided, and you can see that this is the support. So it develops near the support at mid depth and grows towards the top and bottom faces. Is going toward top and it is reaching at the bottom face. So closed loop stirrups. Closed loop stirrups. Most of the students which they have read that stirrups are provided. So closed loop stirrups are provided to avoid such shear failure. Shear damage occurs when we can say that area of these stirrups is insufficient. In the second diagram, we can see that how to provide uh, longitudinal steel bars, means the location and amount of longitudinal steel bars, how we have to provide these steel bars. So from the diagram, it is clear that in this portion, the reinforcement is provided. This is the bottom steel at support. We can see from this green color, these are the bottom steel at support, and it should be at least half of that of top. At support, bottom steel, it should be at least of half of that top, and this one, these bars, at least 2 bars should go full length of the beam. We can say that 2 bars, they are going full length of the beam. From one end of the beam to another end, 2 bars are provided. And these stirrups, you can see, these are the total amount of steel which we are going to calculate. So these are the total amount of steel which we are going to provide in the beam design. So whenever we are designing beam, we have to check that these two types of failure should not be there: flexure failure and shear failure. And the next one is how columns in building resist earthquake. The first example, this is the column failure. We can see that this whole column is damaged. Steel reinforcement is provided, and it is totally damaged. So, what do you mean by this? As we know that column, it is mainly provided longitudinal bars which are placed vertically along the length. Longitudinal bars which are placed along the length. And the second one is closed loops of small diameter steel bars. We can see that these are the transverse ties. These are the ties placed horizontally at regular interval along the full length of the column. So column can sustain two types of damage. Two types of damage can be there in columns. First one is axial failure, and second one is shear failure. As previously we see that in beam there are two types of failure. Same in column, two types of failure can be there: axial failure and shear failure. Shear failure is brittle. Shear failure is brittle, and it must be avoided in columns by providing transverse ties. I will explain this totally. So shear damage can be avoided by providing transverse ties at close spacing. What should be the design strategy when we are designing the column in RC building? Designing columns, it involves selection of material like grade of concrete and steel bars. uh, what type of steel we are going to use and what is the grade of concrete, we have to take care of that. We have to choose different shape and size of the cross section. We have to calculate the amount and distribution of steel reinforcement. So first two is expect which I have explained, that a grade of steel and steel bar. These are the most important parameters which we have to take care while designing the column. Now, how vertical bars and closed ties are placed in columns. Uh, Vertical bars, or first, if we see closed ties which are horizontal, they are given in three categories. First category can be which carry the horizontal shear forces which are generated by the earthquake. So closed ties can resist three types. First is they carry the horizontal shear force which are induced by earthquake, and hence they resist diagonal cracks. In one diagram we have seen that there was diagonal cracks. So ties, they resist the diagonal cracks. Second property of providing ties are that they hold together the vertical bars. Whatever the vertical bars are provided, the closed ties hold together. They do not allow the bars to move outwards. And a third one is that they contain the concrete in the column within the closed loop. And, it is damaged one, but in actual means good design, this stirrups, this closed ties will means they will contain whole concrete within the column. So the end of ties must be at 135 degree. Whenever the end of ties should be provided, in this diagram we can see that it should be at 135 degree. It should not be parallel to this bar. Otherwise, whenever earthquake will be there, whenever earthquake will come, it will get open. But if it is parallel to what means this vertical, or another end is parallel to this, so it will get open. So for safety, we have to incline this at 135 degree. This closed ties. So these hooks prevent opening of loops. They will prevent the opening of loops and bulging. Means concrete will not get bulged, and also buckling of vertical bars will not be there. Vertical bars will not go outwards. So what Indian standard means, what 1893 has given, that closely spaced ties must be provided at two ends. As we can see from this diagram, closed ties should be provided at the two end of the column over a length not less than the larger dimension of the column. Whatever the larger dimension of the column is there, they should not be provided, means less than the larger dimension of the column. The larger dimension of column should be 1/6 of the column height, or 450 meter, 450 mm. So either 1/6 of the height of column or 450 mm. So whatever should be the larger of means if we are calculating either 1/6 of the height of column or 450 mm, whichever is larger. So the end of this closely spaced ties should not be less than these maximum values of these two. Next is we can see from this diagram the spacing of these ties, at what distance it should be placed. So it should not be more than d/4, and it should not be less than 75 mm and or more than 100 mm. So these are the certain criteria which IS standard has given, that ties required in region this. In this region, ties are required. This is the joint beam. Beam and column joint is there. So this region required the ties in the joint region. these are the closely spaced ties. Here joint is not there, so spacing can be more, and but it should not be more than d by 2. Spacing here and here is different of ties, because here joint is there, so spacing is less, and here joint is not there, here column length is there, so spacing it can be more, but it should not be more than d by 2. Again, at the center, at the mid of this column, this the spacing of ties should not be more than the smaller of these two values, either d by 2 and 1 by 50 mm. Again, the same, we can say that this is the replica. Same at here, d by should not be more than d by 2, here d by 2. Same concept at join, at top, at bottom. Yeah. So these criteria we have to follow whenever we are designing the column in RC building. So if we are providing this, this is the mid height of this column. So at what height we have to provide this close spacing and this spacing? So this should be HC by 4, means whatever the height of column is there from this beam means end portion to this beam portion. Suppose if we are taking this as HC, so this portion should be HC by 4, means 1/4 of that height of the column, and this portion, at this portion, we can say that middle half of the column, so where lapping of vertical bars is given. Here lapping of vertical bars is provided. And at these portion where the joint is there, at least larger dimension of D or H by 6, whatever the height of column should be there, H by 6 and 450 mm. So out of these, whatever the larger of these, out of these three, whatever it should be there, it should be this height, this top and bottom of this beam joint portion. This is the D. Whatever we are telling here is D by 2, D by 3. So this is the D. So like this, we have to provide the vertical bars and closed ties in column, because whenever we are designing the building, we have to provide a strong column and weak beam theory, so that if building gets collapsed, so there will be certain time to get escape from the building, and minimum loss is should be there. Next is these are the certain means images when Bhuj earthquake was there. So when Bhuj earthquake comes, many houses and many places damage was there, as we can see from certain examples. These are the certain means cracks when earthquake was there, Bhuj earthquake was there in building. So these many of the building get collapsed in these earthquakes whenever means when Bhuj earthquake was there, and certain bridge. Here, as you can see from this diagram, that certain bridge, and they also get damaged. The damage was not of much, but most of this vertical spires, they get damaged, and means either they have to replace totally, or they are of no use after this earthquake. We can see that this portion get damaged. So these are irreparable. Means we have to change this. Otherwise, there will be problem of movement of the vehicle. Or we can see that this portion of the bridge, it get totally damaged. Means whenever vehicle will move, it can get collapsed, and there will be more damage. So these are the certain bridge when earthquake was there in 2001. So these are the certain images which are there in earthquake. These are the certain references where means you can go, or which I have also adopted for this presentation. So this is very good website nicee.org. Full information of earthquakes in India means this is a collaboration of certain government organization, and at this website you can get every means news of earthquake, every code revision, and whatever the information related to earthquake are there, this gets updated in this nicee.org. And certain information for this PPT was also taken from IIT Kanpur, and one professor from IIT Kanpur is there. He has given earthquake tips. Very good tips are there. You can go and you can see where basic means all the we can see means whatever the images I have shown you in this PPT. Most of the images was from this IT Kanpur professors earthquake tips. So they have explained in very means good language and very basic language where whole things are explained whenever earthquake comes, what we have to provide at beam, column, slab, foundation, and this is the government organization website where the information of earthquake is given. This also gives the information regarding earthquake. Delhi government Delhi government has given one website for all the earthquake related information, and Gujarat government has also given one website, isr.gujarat.government.in, where all the information related to earthquake we can see from these websites or these links. So this was regarding from the presentation. Thank you to all.
Thank you, Anil sir, for giving us such a good session.
If you have any question, you can ask, and I will give the answer to this.
No, sir, I have no any question.
Okay, so I thank to Rohit sir and everyone of this team. They have provided me this opportunity to means this opportunity where I have given this lecture in the Karel University. So I thanks to everyone for giving me this opportunity. And if you have any query, you can mail me or you can ask me. Uh, I will wait for certain minutes. You can ask me, or you can post your question in chat box where I'll answer to your query. Or I have certain video. If you want, I can show you regarding means certain images I can show.
Yes, sir, you can show that.
Is it visible? Visible?
Pictures also.
Whether it is visible?
Yes, it is visible.
So
Yes.
these are the images of the means post earthquake images where this portion get damaged, and this was the portion
No,
of column.
your screen is not visible, sir. Your presentation is visible.
Okay. Is it visible now?
Yes. Now.
So this is the image where this is the image of Bhuj earthquake also. Means the same where the column get damaged when earthquake was there, and the whole building has to get means whole building was abandoned after the earthquake. And this which image I have shown, bridge failure. This the land structure where the cracks are there, and it is major cracks where at certain depth the crack was there, and it was very severe. This is clear image where whole ground setting was there.
Image sir बंद है पीछे.
Hello.
Wait, sir.
Hello.
Yes, 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 Anil sir.
Yes, sir.
Images is not
So
the
it is
images
not
are
coming.
not open. No, yes, yes.
Uh, so these were the certain images which I wanted to show you. So if anyone has question, they can ask. Otherwise, I will end the session. Hello. Hello.
Yes, sir, Anil sir. Yes, sir.
So if anyone has query, they can ask. Otherwise, I will end the session.
Okay, okay. Okay, sir. You now you can end your session. I think
Okay.
anyone has no query.
Okay. Thank you.
Jiten sir. Hello.